Where are you going? How fast were you going? And did you speed up on your way? All these questions are answered by position, velocity, and acceleration. Come along and I'll show you how to figure all of that out. Be sure to subscribe and share this video with another calculus student you know. Position, velocity, and acceleration. That's what we're going to talk about today. So the first thing you need to do is get this information in your notes. I'm going to tell you all about position, velocity, and acceleration. Then we will do some example problems. So get out a piece of paper, maybe a different color, something to put your specific notes on so they're easy for you to find and grab. So first thing you have here is position. And what do you need to know about position? Position is noted by the variable s with the parentheses around t. T stands for time, okay? So if you're not sure about that, make sure you get that in your notes. In fact, I'll make sure to note that the t is representative of time, all right? S is used to represent position, and we're talking about things like feet, miles, okay, that show distance, okay? Next, velocity. Velocity here is the derivative of position. So notice here's our position equation, and this symbol right here means derivative. So velocity, velocity of time, there's that t again, is the derivative of position. Now this will also tell you direction. So for example, if you are headed to your house and your best friend is headed to their house, your signs, either positive or negative, will be different. But if you're both driving a speed of 35 miles per hour, that's down here, your speed, the absolute value of that is the same. So you're both driving 35 miles per hour, but in opposite directions, okay? The units for velocity are going to be feet per second or miles per hour. It is going to be a distance per time, right? That's velocity. It's a distance you're traveling per time. Now, acceleration is the derivative of velocity and the second derivative of position. So we've got the derivative of velocity, your v prime t, always in terms of time, and your second derivative of position. Notice that the notations for acceleration are feet per second squared or meters per second squared, okay? So the time unit is squared. Something make sure you pay attention to, that time unit is going to be squared for acceleration. Let's talk quickly about what happens when you have velocity and acceleration together and what happens if their signs are the same or if they're opposite. So we're going to use this number line. I'm going to put 0 in the center here. This is our 0. And over here on this side, we have negative velocity, right? I'm going to do 2, and you'll see why here in a second. And over on this side, we have positive velocity. Now we have to talk about the two different types of acceleration. If you have positive acceleration or negative acceleration. So velocity is telling you direction. So negative velocity, we're moving this way, right? But when our acceleration is also negative, that means those forces are working together. They're helping each other out. So this is like you're going backwards super fast. So this right here means you're going to be speeding up. When your signs are the same, you're going to be speeding up. Now, if your signs are different, you're going to be slowing down because your velocity is going one direction. It's like you're going on backwards, but your acceleration is like you're pushing on the brakes. So those forces are working against each other, so you're going to be slowing down. Same thing when we go to the other side of 0 with velocity. So let's say you have a positive acceleration here and a negative acceleration here. Over on the right side, your velocity means you're heading in that direction, and your acceleration means you're stepping on the gas and you're going faster. So since these two signs are the same, you're going to be, again, speeding up. Now, on the flip side of that, if you're heading in this direction, but again, you're pushing on that brake, that's what it means when those signs are opposite of each other, you're going to be slowing down. And this is going to be important when we do our example problems. So make sure you get this in your notes, that when velocity and acceleration have the same sign, you're going to be speeding up. And when velocity and acceleration are opposites, you're going to be slowing down. All right, in this problem, they gave us a position function that's noted by s of t, and they want us to find both the velocity and the acceleration. So all we have to do, take the derivative. So velocity, v of t, is going to equal 6t squared minus, that's a 21t squared, so that's 42t plus 60, and then of course our constant will fall off. Now let's do our acceleration. I'll do that in green. So again, acceleration now, we're just going to be taking the derivative of our velocity equation. 12t minus 42. There we go. Part A, done. Now the second part wants to know when you have stopped. So think about this. When you are driving in a car and you're heading in one direction, and then you want to go, turn around and go back the other direction, what has to happen to your vehicle? You have to stop, right? And which one of these, position, velocity, or acceleration, tells us direction? If you don't remember, look back through your notes. Direction is velocity. And if you're going to change directions, that means your vehicle has to stop. So we want to know when our velocity equals 0, because that means that our vehicle has stopped. So the first thing we need here is our velocity equation, and I'm going to write that out first. Here's our velocity equation. What we want to know is when this thing has stopped, and it has stopped when our velocity equals 0. So I'm going to set this equation equal to 0, and I'm going to notice that there's a 6 in all of those numbers on the right-hand side. I'm going to pull that out, make this a little easier. T squared minus 7t plus 10. That's going to make this part much easier to factor. 0 equals 6. Set up our double parentheses. So you need a number that multiplies to give you 10 and adds to give you negative 7. And it's a positive 10. So we're going to do t minus 5 and t minus 2. That'll give us negative 7 in the center and 10 on when you multiply. Set each of these equal to 0. You're going to have t equals 2 and t equals 5. So those are the times when your vehicle has stopped. Now we want to know when the particle is speeding up or slowing down. So remember, to find out if it's speeding up or slowing down, you need to know information about both velocity and acceleration and when the signs are the same. The easiest way to do this is a number line analysis, and that is what we're going to set up. But to set up a number line analysis for acceleration, we first need to set that function equal to 0, right? Because that's the easiest way to tell when it's changing from positive to negative. So that's what I'm going to do first. Our acceleration equation is 12t minus 42. Set this guy equal to 0. Is this thing going to go in evenly? Unfortunately not. But they both share a 6. So this will go in 7 times, and then it'll go in 2. So 7 halves. So, or you can write 3.5. Whatever's easier for you. But that's the time when acceleration is going to equal 0. Next, we're going to set up our number line analysis with both of those information. So if you remember, our velocity equals 0 at 2 and at 5. So here we have our velocity information. We have our original equation and when t equals 0. I'm going to stick this on a number line. Velocity equals 0 when t is 2 and when t is 5. So what we need to figure out now is, are these signs in between positive or negative? Well, you could easily see if you plug in like a 0 to this equation. This is what I'm going to use. I find this a little easier to work with than that guy up there. If I plug in a 0 to this guy's going to be positive. If you plug in a number between 2 and 5, this piece here will actually be bigger than this guy, so this is going to be negative. And then any number after 5 will be positive. So now what we need to do is to compare this to the number line analysis for when acceleration is 0. So now we're going to do our acceleration number line analysis. And our acceleration equaled 0 at 3.5. So that goes, and notice I'm going to line it up right in between these two. So it's kind of easier to see when it's going to be speeding up and slowing down. So now if I put in a number to the left of 3.5, so I stick in 0, this guy is going to be negative. And if I put in a number greater than this side is going to be positive. So notice we have some overlap here that we're going to have to identify. Because what happens, I'm going to extend this negative sign so you can see that a little bit more. But when this 2 comes down, right, because this was the 2 from velocity, this side is positive velocity. This side of it is negative velocity. And all this is negative acceleration. So what does that mean? This piece here is slowing down, but this interval here is speeding up because those two signs are the same. Now let's do it with 5. The 5 comes right down here, and I'm going to make, this is a plus, make this, so you can see that both the acceleration is positive on that side, okay? But now my velocity on this side is negative, but my velocity on this side is positive. These two signs are opposite, so they're slowing down, but these two signs are the same, so they're speeding up. Right? It's a lot. So now we need to identify which intervals are speeding up and slowing down. Again, when the signs are the same, they're speeding up. So let's look at the number line analysis and see where they're the same. They are the same, right here I did a arrow going up, between 2 and 3.5. And it's also speeding up from 5 until infinity. Now let's identify when it is slowing down. When the signs are opposite, it's slowing down. So from negative infinity to 2, we're slowing down. We're also slowing down from 3.5 to 5. All right, next they want to find what is the total distance traveled. So this means your odometer. What does your odometer read on your car? I don't care if you drive to your friend's house and come back home again. It's not going to be 0 where you started, right? I want to know how many miles did you drive there and how many miles did you drive back. So the way that we figure that out is we have to look at how far the car drove before it stopped. And then when it stopped, how far did it drive again? And in this problem, they only want us to work with when t is 0 and when t is 5. So again, what deals with distance? Do you remember? Hopefully you do. If not, flip back in your notes. It is velocity. So again, how do we know when we change directions? When velocity equals 0, which, thank goodness, we've already figured out. But now we just need to know what your position is at those points, which means we need our position equation and the time when velocity equals 0. The first thing we have to figure out is what was your position when we started? What was your time before you started? Your time was 0, right? The other indication is they give it to you up here. They want to know from t is 0 to t is 5. So that's the first place we have to go, at 0, and then we know that the car stopped at 2. So we're going to figure out both of those positions. So S of 0, we're going back to our position equation because that tells us where you were when you started. And if you stick 0 into these, guess what you're left with? 3. So when S is 0, your position was 3. Now to find out the rest, you can stick them into your calculator and just plug in the equation, Or what I do is I go to my y equals on my scientific calculator. I put this function into my y equals, and then in the graphing capabilities, you can evaluate x at a specific number, and it will give you the y values. When you do that, you'll find that s of 2, when your position's at 2, you're at 55. And at time 5 seconds, your position is 28. Now you have to figure out how far you traveled. So we're going to draw a little map to show where you went. When t was 0, you started at position 3. Then, for 2 seconds, when t equals 2, you ended up at 55. Let's just stop here for a minute. How far did you drive from t equals 0 to t equals 2? You went from 3 to 55. So hopefully you're seeing that this space here was 52 units, right? 55 minus 3, 52 units. That's how far you drove. But when t was 2, you stopped, right? You stopped and you came back and you went another direction. And from 2 to 5, you went 28 units. So I'm just going to do a dotted line up here. You drove back this way when t equals 5. This is still when t equals 2. You drove back to 28. How many units spans that distance? 55 minus 28 is 27. So now we need to find out your total distance. So all you have to do, add those two together. 52 plus 27. You went 79 units. That is your total distance. Now, what happens when they ask about your displacement? Where did you end up when all of this is said and done? So if we don't look at your odometer on your car, and we only want to know how far did you go from where you were to where you ended up. So we can go back and use the same little map that we just drew. Now basically what we're saying is we want to know from where you started to where you ended up. I'm going to bring it straight down here. All we want to know is this part in between. How many units is that? You can actually do this two ways. The easiest way to do it is to see that you ended up at 28 and you started at 3. 28 minus 3 is 25 units. The other thing you could do is take 52 minus 27 and you'll get 25 as well. So either way that you want to do it is totally fine, but know the difference between distance, how far total did you go with your odometer, and displacement. Here's a quick thing to put in your notes. Make sure that you get that distance is the total miles traveled, is what your odometer in your car would read, okay? But displacement is just the difference from where you started to where you ended up. Hopefully this video helps you understand position, velocity, and acceleration just a little bit better. If it does, be sure to subscribe. Also, if you have any comments, questions, or have a topic you want me to cover, be sure to add it in the comments below.
Bye!